I don't think that's a good idea. I think we'd be better off just doing them all.
Okay.
Okay. So let's see. I think we got through 4 last time. Yeah. Actually, we didn't do 4. But do you know how to do 4? Do you know how to cube a binomial?
Mm-hmm.
Yeah, just multiply it by itself 3 times. Now, when you multiply it by itself twice, you're going to have a trinomial. So the third step is multiplying that trinomial times x plus 3.
Mm-hmm.
Okay? So you have to do that in pieces. All right, let's go to number 5. Tell me what the next line is, and I will write, rather than me writing the problems over here from scratch, I don't think that really is needed because you can see it. Just give me the next line.
Okay. So it's going to be 2x plus 8
Okay.
equals 5x minus 12.
Now, at this point, you have to decide whether you're going to move your variables to the right side or the left side. And then you're going to put your numbers on the other side, wherever the variable is at. So what makes the most sense as to which side to put the variables on?
Let's put them on the right side.
Because it leaves the coefficient positive, and that's what you want.
Mm-hmm.
And that's what you use to determine. In other words, whatever is going to leave you with positive numbers is always better than negative numbers. And if I move that 2x to the right, so let's do both steps in one. In other words, once we've decided we're going to move the variables to the right, we're going to move the numbers to the left. So put all numbers on the left, all variables on the right. What's the next line?
So subtract 2x and then add 12. So it would be, wait, 8.
I'm usually very much in favor of doing one step at a time. This is the one exception. Since you're doing variables and numbers, you can do both steps at the same time. So what number is going to end up on the left?
It's going to be 20 equals 3x.
Okay, and the next line?
And then divide that by 3.
So what's the next line?
Oh.
X equals what? You don't need to put it into a decimal. Leave it as an improper fraction.
Okay.
Always. Improper fractions are better than proper fractions. Always. Believe it or not. And primarily the reason for that is that when you go up into higher math, the ratios are more important than the numbers. So you never convert improper fractions to proper fractions. So what do you get? X equals what?
20 over 3.
Mm-hmm. Okay, next problem. Number 6. What's the first thing you're going to do on number 6?
Distribute the 4 to the u and the 2.
Do only that. Like this is a situation where you really only want to do one step at a time. Okay.
Mm-hmm.
So what's the next line if I do that? Still got the
minus
x. I'll use brackets. Okay. Now what?
It's going to be u minus 4u minus 8 bracket.
Good. And that's all equal to 5u minus 4. Next line.
Mm-hmm.
You don't even have to tell me what you're doing. If you can give me the next line, I'll know what you did. Okay.
Okay. So it'd be positive 18u.
Hold on. So all you're doing is multiplying minus 6 times. Oh, I see it.
Oh, okay.
Okay.
Yeah.
I was behind you there. I forgot. In other words, you combine those. So let's make the next line this. Minus 6 times minus 3u minus 8. In other words, let's not do both of those steps at once. And in fact, I'm just going to make a blanket rule. Let's always only do one thing at a time. Okay? Forget what I said about doing two things at once there. I don't think that's the way to teach anybody. Now what's the next line?
So it'll be 18u plus 48 equals 5u minus 4.
And what's the next line?
It would be 13u equals negative 52.
Good. And notice that on this one, no matter which side we put the variable on, something's going to have a negative in front of it. So it doesn't really matter on this problem whether we move the u's to the left or the right. But what I usually do is the only sign I'm really going to worry about is the coefficient of the variable. So I focus on making that positive. So I would always do exactly what you did here, which is move the variable to the left, which means you're always going to move the other one to the right. And what's the next line?
U equals negative 52 over 13.
Can that be simplified? You play cards?
No.
You don't play any card game?
I mean, not that often.
Well, there's 52 cards in a deck, and there's 4 suits. And there's 13 cards in each suit. So what's 52 divided by 13?
4.
So the answer is U equals minus 4. In other words, you don't want to leave stuff in ratios if it can be simplified. You always want to simplify. Okay?
Okay.
But there's no need to say 7/3 is equal to 2 1/3. You don't want to do that. You want to leave your answer as 7/3. Wouldn't be wrong. You certainly wouldn't lose points if you gave that answer. But there's no need to turn it into a proper fraction. It just isn't necessary.
Okay.
All right, that one was 6. About 7. Let's have a look at 7. Let me go ahead and write it just because there's a lot going on with it. Tell me what the first thing you're going to do is.
Distribute the negative 2 to the r plus 3.
Okay.
On the left side. So it would be 2r minus 2r minus 6.
Equals. Now, as long as we're doing something, let's do something on the right side too. Let's distribute what, in other words, we're going to work from the inside out. So
you do 4 and then the bracket 2r minus 3 minus 3r.
Okay. Now, next line.
It'd be negative 6 equals 8r minus 12 minus 12r.
And the next line.
It would be So 6 equals
Negative 6 equals, yeah.
Negative 12 minus 4r.
And the next line.
6 equals negative 4r.
And the next line.
Divided by 6. So r equals
5 by 4. Negative 4.
Mm-hmm.
Okay.
So then it'd be r equals negative 6 over 4.
And does that simplify?
No, it could be 3 over 2.
Yeah. Anytime you have an even number divided by an even number, you know it simplifies. Always. Because you can always divide top and bottom by 2. And so when you have even numbers, just keep dividing it in 2 until you get a prime, until you get an odd number there. And now that's fully simplified. All right. Let's go to these word problems. Number 8. Everybody loves word problems. I'm sure you do too.
I don't think they're as bad as everyone else does.
What's that?
I don't think they're that bad.
No. Okay, good. All right, so you're at a restaurant. They charged an 18% tip, and your total bill was $163.43. What was the bill before they added the tip?
So you have to find 18% of that.
No.
So you multiply it by...
Hold on, stop for a minute. That's
Okay.
not true. If I take the number 100 and I drop it by 10%, what's it go to?
90%?
90. Now take the number 90 and raise it by 10%. Go to?
Would be 100.
No. Take 10% of 90 and add it to 90.
Oh, this would be 99.
So what that tells you is that when you're taking a percent down and then adding the same percent to get back up, you don't get back to the original number, ever. Let's take 50% of 100. That would make it 50. And now if I increase 50 by 50%, it only goes to 75. It does not get back to 100. Well, the same principle applies on this problem. In other words, one other thing. Let's say the bill is $10. Now let's make it $100. And they tell you that there's an 18% tip required. How do you figure out your total bill?
Take 18% of 100, so it would be $118 total.
Correct. But there's actually a faster way to do it. What you did was take 18% of this and then added it to 100, right? That's the same as multiplying it by 1.18. And that's an important consideration to know. When you're talking about tips, anything that increases the bill, you don't have to multiply it by 18% and then add it. You can just multiply the whole thing by 1.18. Notice that also gives you $118. Okay? And this is important because what we need to do is set up an equation for this problem. Okay? So the total bill, let's let be X. Let X be the original bill before tip. And let me tell you the secret to word problems. always define your variable first and be very specific as to how you define it. Okay? If you do that, word problems will truly become a piece of cake, because once you've defined the variable, now you can write an equation. So what's the equation that I can write? If x is my original bill,
so x,
I'm going to take my original bill and I'm going to multiply it by 1.18 times x, and that's going to equal my final bill.
okay.
Okay. Now it's an easy algebra problem. Now what do? What's the next line?
Just divide 163.43 by 1.18.
Now this is something clearly on a test, you wouldn't want to leave it in that ratio. You'd want to use your calculator and carry out whatever this number is as your answer. Okay? And believe me, it's not the same as taking 18% of that number and subtracting it. Because in one case you're going down, in the other case you're going up. That's like I did in my example. So always try to set up the equation and then solve it. These word problems, that's what they want you to do. They want you to set up an equation. Okay. All right, number 9.
So it would be,
how are you going to do it? What's your total annual earning?
$44,550.
Well, plus that year-end bonus. Now this is an odd question, actually. Very odd question. Because the question is do they pay you the year-end bonus at the year-end, or do they include it in your paychecks that are issued twice a month? I'm going to assume they include it in your paychecks. So what's your total salary for the year?
It'd be $45,300.
Okay. And now you get 2 paychecks a month. So how do I figure out what paycheck each paycheck's going to be?
Divide that by 24.
Perfect. What do you get?
You get $1,887.50.
That's what each paycheck's going to be. Assuming that they pay you your year-end bonus throughout the year. And that's not really the way the world works. The way the world works is that you would take this $44,550 and divide it by 24. That would be the amount of each paycheck. And then at the end of the year, they'd give you a check for $750. Okay? But I don't think that's the way they wanted you to do this problem. They didn't specify whether that year-end bonus was paid, with each paycheck or whether they waited till the end of the year to pay it. The year-end bonus usually is the end of the year, but I don't think in this problem that's what they mean. I'm going to skip everything and just go straight to the problems. Because if any explanations needed, I can provide it.
Okay.
All right. Inequalities are very much like solving equations with one difference only. And that difference is that whenever you divide or multiply both sides of the equation by a negative number, you have to switch the direction of the inequality sign. With me?
Mm-hmm.
Okay, what's the next line?
So it would be 5 times x minus 3 plus 1
Hold on.
is...
We might as well distribute the 5 on the left side and the 4 on the right side, all in one step.
Okay.
Because that's not really doing two things at once. It's just working left to right.
Okay. So 5x minus 15 plus 1
Okay.
is less than
Greater
negative 4.
That's a greater than sign.
But don't you switch the sign when there's negative?
No, you have to multiply or divide both sides by a negative number. And so far we haven't done it.
Okay.
Okay. In other words, let me just skip to one I'll make up. If I said minus 2x is greater than 10, well, I've got to divide by minus 2, right?
Mm-hmm.
Okay, so now I get x, switch the sign, minus 5. So this is what I mean, that when you have to multiply or divide by a negative number, you have to switch the sign. You still go ahead and divide by the negative number. You don't change anything except switching the sign. Now, whether we'll need to do this on this problem or not, I don't believe we will, but let's finish it so that we can tell.
Okay. So that is greater than negative 4x plus 4.
Okay. Now, what's the next thing you're going to do? Well, let's combine the minus 15 and 1. That makes it minus 14. Let me see if my eraser is working. All right, so we're there. Now what?
Would you add 4x to the left side?
Correct.
Okay. So it would be 9x minus 14 is greater than 4.
Okay, and then the next line?
Then you'd add 14 to the right side, so it would be 9x is greater than 18.
Yeah. Next line?
X is greater than 2.
Yeah. And notice that nowhere in there did we divide or multiply by a negative number. You can subtract negatives or positive numbers without changing the direction. It's only when you multiply or divide. Okay? All right. The second line on number 11. I'm not going to do anything with the left side of the inequality. What's the second line?
Second line is 10x plus 15.
Okay. Question. Are you going to be allowed to use a calculator when you take this test?
Yes.
Okay, good. All right, next line.
Let's say 7x plus 2 is less than or equal to 15.
Where are you getting 7x from?
Oh, just kidding. It'd be 13x, because, yeah.
Okay, read it to me from left to right.
Oh, okay, so it'd be 2 is less than or equal to 13x plus 15.
Plus 15, okay. And the next line?
Then it'd be negative 13 is greater than or equal to 13x.
Less than.
Or less than.
Yeah, I still have not divided by a negative number. And
then you just divide by 13.
Okay.
So negative 1 is less than or equal to x.
Good. Okay. Number 12. I'm going to write this one out because this is a little different. What's a good first step here?
I would say try and get rid of the denominator of the fractions.
Very good. Very good. In other words, a mistake would be to distribute the 5/7.
Mm-hmm.
Because then you're just going to have more complicated fractions. Notice you're going to end up with a minus 15/7 on the left. Okay, at least I think that would be a mistake. To me, when you have fractions, denominators basically, in an equation or an inequality, the best first step is to try to get rid of that denominator. Turn everything into whole numbers only. Well, what can I multiply both sides by to get rid of the denominator?
7.
Yeah, exactly. So give me the next line. Multiply the left side by positive 7 and multiply the right side by positive 7. What's the next line?
All right, so it would be 5x minus 15
Okay.
is greater than or equal.
2 steps in one, but I don't have any problem with that.
Okay. Is greater than or equal to 4x.
Nah, you got to multiply every term on the right side by 7.
Okay.
In other words, if I'm multiplying the left side by 7, I got to multiply the right side by 7 like that.
Okay.
That means that 7 has to multiply by the 4x also.
Okay.
Okay.
So then it would be 28x plus 22.
Yeah. Now notice how much easier that is than what we started with. In other words, by merely multiplying by that denominator, we've turned it into a very easy problem without fractions. What's the next line?
It would be negative 15 is greater than or equal to 23x plus 22.
And the next line?
So it would be
What kind of calculator do you have? Just a
currently.
Is it a Inspire or a TI-80?
Yeah.
It's an Inspire?
Yes.
Okay. All right. Those are good ones. That's top of the line calculator. In fact, I don't know of any that's better. So.
Negative 37 is greater than or equal to 23x.
And the next line?
Negative 37 over 23 is greater than or equal to x.
And what if I wanted to put the x on the left side here? What would I do?
I would just...
Let's just say that I wanted to do that.
Would you have to flip the sign too?
Yes. In other words, if you're flipping, once you get it in this format, and you feel more comfortable with the x on the left, you can do it. You can just switch them, but you have to switch the sign. Okay? You don't change anything else. Just switch positions and switch that sign. Notice that this says exactly the same thing as that. In other words, if I look at the top circle, it's x is less than that number. And if I look at the bottom, it's x is less than that number. Now, can I simplify that number, that ratio?
No.
How do you know?
Because you can't... because the numerator is bigger than the denominator.
Well, they're both prime numbers. Notice.
That's also true.
There are no factors of 37 other than 37 and 1. And there are no factors of 23 other than 23 and 1. So if you have a prime number divided by a prime number, there's no simplifying it, just based on the definition of prime number.
Mm-hmm.
Okay. All right, let's see. That was number 12. Let's do one more just to get through this section.
Okay.
Besides that, you're doing them pretty fast. The first line, go ahead and multiply those two things together.
Okay, so it'd be 2x squared minus 3x
Go ahead.
plus 4x, so it'd be
Plus,
plus x
right. In other words, I don't mind doing that little shortcut. Okay.
minus 6
Okay.
is less than.
Now, what do you want to do on the right side first?
Do you want to multiply
I
x plus 4?
I don't know that one is easier than the other. You could distribute the two to just one of these terms and then multiply the two together. I personally prefer to multiply these two things together and then distribute the two. So I'm going to leave
Okay.
the two outside for the moment. Now multiply those two binomial linear factors together. What do you get?
It would be x squared plus 6x plus 6.
Plus 5.
5.
One times 5 is 5. Okay. Now distribute it.
So then 2x squared plus x minus 6 is less than 2x squared plus 12x plus 10.
Okay. Now what's something you can do automatically just by looking at it?
Could you?
Cross off the 2x squareds.
Yeah.
In other words, what I'm basically doing is subtracting 2x squared from both sides. But the fact that I've got one over here and the same one over here, and neither one of them is multiplying anything. If they were multiplying something, I couldn't do that. But the fact that they're being added to something, well, I can always do that. I can always cross that off and it leaves 0 behind. So now I'm left with x minus 6 less than 12x plus 10. Next line.
It would be x minus 6 is less than 12x plus 10. So then you would.
For this case only,
It would be negative 6.
Move variables to the left, just for this problem only. In other words, normally I would say move the variables to the right, because that'll give you a positive coefficient. But when you're dealing with inequalities, a lot of people are very uncomfortable with having the variable on the right side of that inequality. They just don't like it. So when you're dealing with inequalities, I would say always move the variable to the left.
Okay.
Okay, so
then it would be
to the left, what do you get?
negative 11x minus 6 is less than 10.
Okay, next line.
So then it would be negative 11x is less than 16.
And the next line.
Negative x is less than 10 over 16.
Instead of dividing by 11, divide by minus 11.
Okay. So it'd be negative.
Huh? Be positive. If I divide that by minus 11, it turns into x. That's why I suggested that.
Yeah.
It's because you're left with what you want, which is x.
Mm-hmm.
Now what's the rest of it?
So x is less than.
Hold on. This is that one case where.
Oh, yeah, x is greater than.
So x is greater than what?
16 divided by 11.
Well, it's a negative. In other words, you got to do two things. You got to divide both sides by minus 11, and you have to switch the direction of the sign. Okay, you can't just switch the direction of the sign and then drop the negative sign.
Okay.
This is your final answer, and it leaves x on the left side. Now, had I done it the other way, I could have still gotten to this. In other words, if I'd have done it the typical way you'd solve an equation, I would have minus 11x there. I would have minus 16 there. Oh, excuse me, I would have plus 11x there. Minus 16 over there. I would divide both sides by 11. So I would get minus 16 elevenths is less than x. And like I said, most people don't like having their variable on the right side of an inequality. So now if I switch them around, switch the direction of the sign, and I get the same thing I got. But I actually really favor putting the x on the left side immediately when you're doing inequalities. Just, it's easier to think about when x is on the left side. When it's an equation, it really doesn't matter. If something equals something, then something equals something, and you can put either one on either side. But when you're doing an inequality, having that x on the right side is a little confusing. So I always try to put the x on the left side. And then just follow the rules about switching the direction of the inequality sign. Okay? All right, let's end it there. What did we get through? We got through 13. Good. Let me make a note so I'll know where we're at. We're ahead of schedule.
Awesome.
Yeah, really. I think this is going to be very helpful, and this is definitely the source material we should use, as opposed to you finding questions in the book, because this is going to be very inclusive. In other words, by the time we get through all 112 of these questions, you're going to know algebra pretty good. At least you're going to have covered all of the major subjects of algebra that you need to be familiar with. Okay?
Yeah.
Sounds good, Madison. Did you want to, if you happen to know by chance, interesting. Somebody tried to make an appointment. I think they forgot to confirm it. Unfortunately, I don't know who it was. But you can lock up something. In other words, if you know you always want Wednesday at 7:30 and Thursday at 8, I can lock that in right now so that nobody else can ever take those time slots. I just don't know your schedule well enough to know whether or not you want to do that. You might want to just play it by ear and schedule whenever you want.
Yeah, I think that's a good option for right now, just because
Okay.
of the things that I'm doing. The times are always changing.
Yeah,
So.
if you don't know what your schedule's liable to be, then it makes sense to do it that way. And somebody in your family knows how to schedule because they scheduled these 2 appointments. So.
Oh, yeah, I did that. You
did that? Okay. You used my digital math tutor, or did you go to Algebra to Calculus?
I went to Algebra to Calculus.
Okay. Either one uses the same scheduling program. So if you're just trying to schedule an appointment, it doesn't really matter which one you go to. If you're trying to pay, I'm going to say digital math tutor is a lot easier if you're using PayPal.
Okay.
Okay? Just because it's set up a little bit smoother. And it's much easier to use PayPal on Digital Math Tutor than it is on Algebra to Calculus Tutor. Okay?
Okay.
And and you got my emails showing you how to watch these sessions on YouTube?
Yes.
Okay. Did you try it out at all?
Not yet, but I will.
Well, keep it in mind because before you take that test, you're liable to want to review all of our sessions. You know, and the few days before you take that test, you might want to go back and just review all of your half-hour sessions and lock that information in. So, but you're not doing bad. You're doing pretty good. Yeah, I think we'll be able to get through this and probably in a lot less than 12 hours.
Okay, cool.
All right, Madison. Talk to you next time.
Okay, thank you.